Hello and welcome to this short video introduction to the Akka.Cluster module. My name is Andrew Scottsko. I'm the co-founder of a company called Petabridge, and I'm going to be taking you through the Akka.Cluster introduction. What is the module? What does it do for you and your applications? And how can it make your life better as a developer? There's not a whole lot of documentation on this module as of right now, that is June 2015, but we're going to be contributing a lot more docs back over the next few months, and we wanted to start off that effort by giving you a brief video tutorial on the module and how it works. So let's get into it. Akka is a framework for building powerful concurrent and distributed applications easily and more quickly. Frankly, it just makes your life as a distributed systems developer a lot better. In this video, we're going to be focusing specifically on the distributed part of Akka.net. That is, how do you use Akka.Cluster to build applications that can span many nodes across a network? How can you build microservices? How can you create an application that can elastically scale up or down as needed on demand? I'm the co-founder of Petabridge. We're the company that supports the Akka.net project and has the privilege of working with the global contributor community. Petabridge also provides support, training, consulting, and tooling for Akka.net and for distributed systems development in general in .NET. So without any further ado, let's get into it. Let's talk about Akka.Cluster. We're going to be starting with some slides to illustrate the concepts and help you get a mental framework for what is happening. And then I'm actually going to be mixing in some code samples and demos towards the end of this so you can actually see things in action. So here's what we're going to cover in this video. We're going to start off with answering the very simple question of what is a cluster? Then we're going to move on and ask, what does clustering give you? Why should you even care? And then how do you enable it? How do you turn this on? And then finally, how do you actually use clustering in a real application? So let's get started. What is a cluster? We're going to start off by visualizing what a cluster looks like, and that would be this. A cluster is a group of computers working together to accomplish a task. Clustering is also the way you do a microservices architecture in Akka.net. We're going to be getting into that much more at the end of the video, but this is a very simple way of illustrating what a cluster is. So now let's talk about some of the features of what a cluster is. A cluster, first of all, is fault tolerant. It can recover from failures gracefully. Second of all, it's elastic. This is probably the most commonly thought of aspect of a cluster. That is, it can elastically add new nodes to the cluster to grow in size and take on more work, or it can do the opposite. It can shrink in size when it doesn't need the amount of machines it has to save you money. Also, clusters are decentralized. That is, there is no one machine in the cluster. There are many machines. There are no client-server semantics here. There are just servers talking to other servers over open sockets. Everything is done through persistent socket connections. So if you put all these things together, what you really get is that there's no single point of failure in a cluster. And similarly, if you're doing a lot of processing, there is no single bottleneck in the cluster. Akka.Cluster is the module that enables these types of features to exist in your application. And all it takes is installing it and architecting your app in a certain way, which we're going to cover here. So let's talk briefly about what some of the benefits of clustering are. And we've sort of touched on them already, but let's just recap those really quickly. First and foremost, I would say it's elasticity, the idea that you can have very, very scalable systems using clustering. Secondly, they recover from failure really well. These are hard systems to break. And finally, clustering is a very easy way to get all the benefits of a microservices architecture. It's much, much easier to create microservices with clustering than starting with some monolithic app and then trying to cut it up. It's easy to develop it locally, and then you can deploy your application out across cluster, whether that's on the cloud or on your own hardware. And the best part? No code changes. Yes, really. The way that happens through your configuration, through Hokon. And this is a bit of what it looks like. One quick note, just while we're on the topic of configuration, is just that all of the nodes in your Akka.net cluster have to have the same actor system name. You can cross actor system name boundaries with Akka.remote, but that module is a bit beyond the scope of this video. Now that we know what clustering is, when do we use it? Here are some example use cases that fit clustering really nicely. By no means is this all of the use cases for clustering, but these are some of the common ones that I have been seeing in production. Whether you want to use it to build scalable analytics systems, marketing automation systems, if you want to build streaming multiplayer games, or if you want to do device or Internet of Things tracking, you're going to need clustering. Also, if you want scalable monitoring systems or recommendation and machine learning engines, or something like perhaps dynamic pricing for concert tickets. These are all really great use cases for clustering. Now I'm going to walk you through how a cluster is actually formed. Everything you're about to see is powered by what is called gossip. I don't really have time in this video to go deep on gossip, but basically gossip is a lot of back and forth communication between all the nodes in your cluster, and it's used by the cluster to figure out who all the nodes in the cluster are, and also to constantly monitor the status of those members of the cluster. This is the initial state of our cluster. We have 5 nodes, and right now they all exist independently and they don't know about each other. We have A and B, and then C, D, and E. As you can see, there is a little circle around A and B, and they're labeled seed nodes. What is that? A seed node is an initial well-known contact point that other nodes can use to join the cluster. You can configure seed nodes yourselves, or we have something to help you with this, and that is called Lighthouse. Lighthouse is a free dedicated seed node tool for Akka.net clustering. It only has to be upgraded when Akka.Cluster itself is upgraded, and it's not actually deployed as part of your app, so it should never have to be redeployed when you make code changes. But it will need to be upgraded as Akka.Cluster itself gets upgraded. Lighthouse is a free tool developed by Petibridge. Click the link on your screen to get the code on GitHub. Okay, back to how a cluster forms. As we said, we had 5 nodes, A, B, C, D, and E. A and B, being seed nodes, already know about each other, so they start the cluster themselves. A contacts B, B contacts A, and between them, they very quickly form a cluster. Now we have 3 other nodes, C, D, and E, who are not yet part of the cluster. So A and B know about each other, and then nobody else knows about them, and they don't know about anybody else. So what happens is that C and D on the right, they only know about node A as their seed node, and node E only knows about B as a seed node. So each of these nodes will get in touch with the seed node they know about. So everybody attempts to join the cluster through the seed nodes. So C and D try to join the cluster by contacting A, and node E tries to join the cluster by contacting node B. Now C, D, and E have contacted their seed nodes and started to form a cluster with them. A is elected the leader of the cluster, and A, through its gossip with B, knows about a cluster of A, B, C, and D. It doesn't yet know about E. This is when the quote-unquote ring begins to form. As the gossip spreads through the cluster, it informs the other members of the newly formed cluster about each other. E is told about C and D, and A learns about E, and so on and so forth. The communication is also established between non-seed nodes. So now, node C and node D and node E all begin to talk to each other directly. And then they can actually communicate even if a seed node dies. So once your cluster is up and running, if the seed nodes die, that actually will not stop the processing and the work that takes place within your cluster. The other nodes in the cluster, they already know about each other, and they no longer need the seed node to work with each other. The seed nodes just serve the purpose of establishing the cluster in the first place. We now have a fully formed cluster up and running. All 5 nodes know about everybody else. They even know about nodes they did not have any knowledge of before, and who joined the cluster through a totally different seed node than they did. So for example here, C now knows about E, even though it did not know about E before, and both C and E had different seed nodes. Okay, now we have a cluster. Great, at least conceptually. But how do you actually enable clustering in your app? Let's go into that now. Here are the 6 steps you need to take to turn on Akka.Cluster inside your app. First of all, you need to install the NuGet package. Then, you need to configure the cluster actor ref provider. Actor ref providers are like actor factories within Akka.net, and you need to turn on clustering capabilities so that the actors you get back are cluster capable. Steps 3 and 4, you need to enable and configure at least one network transport within Akka.remote. If you're not familiar with it, Akka.remote is another advanced module, and it's actually the module that powers all remoting and all network communications within Akka.net, so it is a hard dependency of clustering. It's also very well worth your time to learn if this is an area that you're actually interested in. Okay, step 5, we need to enable at least one of the seed nodes like we've discussed. And finally, we have to start up our actor system. Okay, I'm now going to actually walk you through those steps one by one within the context of the simple cluster sample, which is a simple clustering demo built into the Akka project itself. The sample will also illustrate for you what cluster gossip messages look like. Let's go to the code. Okay, now I'm actually going to walk you through how to enable Akka.Cluster inside one of your projects. And to do this, I'm going to use a built-in sample to the Akka.net project. It's called samples.cluster.simple, and it lives over in the examples folder. The first step is to install the NuGet package. So we're going to type install package Akka.Cluster-pre. Our next step is to configure the cluster actor ref provider. So we're going to add an actor section to our Akka Hokon, and then we're going to type in provider equals Akka.Cluster.cluster actor ref provider, comma, Akka.Cluster. Our next step is to enable at least one Akka.remote transport and configure the address for that transport. So we add a remote section to our Hokon config, and then we're going to add log remote lifecycle events equals debug, just so we see all the events. Then we need to configure Helios, which is the actual network transport that powers everything in Akka remote and therefore Akka.Cluster. We're going to configure the hostname to be 127.0.0.1, and then we're going to configure the port to be 0. If you're not familiar with what port 0 means, it's basically a special flag that asks the operating system to assign us a randomly available port. So we don't actually know the final port number we're going to end up with, but that's okay because of the seed nodes, which we're going to talk about now. So the final step is to configure the seed nodes. So we add a cluster section to our Hokon config, and then we add the seed nodes, which is just an array of strings. So we're going to add the seed nodes, which are going to be the actor systems we start at Akka.TCP cluster system at 127.0.0.1, port 2551, and port 2552. Okay, now that we have installed the package and configured our cluster actor ref provider, enabled our Akka.remote TCP transport, and added our seed nodes, we're ready to go so we can start up the system. Okay, we can clearly see something happening here, so I'm going to take a minute and just walk you through what these messages are. So up at the top here, we can see that remoting has started and that the cluster is starting to form. All these warning messages, don't worry about them. This is one of the actor systems trying to contact the other seed node, which is not yet up and running, but it's going to back off and retry. So then we can see that there are joining messages. So our two seed nodes are up, and then our dynamic node is up, getting a welcome message from the leader. And then from here on out, we actually have a fully formed cluster, and it doesn't look like much, but that's what this is. The rest of these messages are actually just gossip messages. If you've been wondering what gossip looks like, this is it. These are just messages bouncing around nodes in our cluster, so it's up and running. This is great, but what makes this all possible? The answer is actually very simple. It's location transparency. The idea of location transparency is actually really well illustrated by a cell phone. If I want to call you on your cell phone, I don't actually need to know where you are. I just have to know your phone number, and then I can call you, and whether you're in Los Angeles or New York or London or somewhere else, it's not my concern. It's the job of the cell phone network to route the voice packets from me to you and back, regardless of where either of us is. That's exactly what location transparency means. This is the same thing that's happening within the cluster itself. The location of the actor within the cluster doesn't matter. You don't care if the actor is actually on node A or node E or F. It doesn't matter. This property of location transparency is essential because it's what allows you to write your apps locally on one machine and then scale them out across hundreds or thousands without having to worry about it and just let the cluster do it for you. Without location transparency, you could not do that. Now, how do you actually use clustering in an application? We're going to go into our favorite use case for Akka.Cluster, and that's microservices. Microservices, if you're not familiar with it, is the idea of having multiple independent services all on separate physically isolated machines collaborating as a unit. What happens is that we run multiple Akka.net applications within a cluster. Each application is on a node and has a job to fulfill, and these all collaborate within the cluster. This is how we create scalable microservices within Akka.net. And what powers all of this is roles and cluster-aware routers. I'm not going to go into routers in this video, so you should check the docs, but I'm going to go into roles now. What is a role? A role is nothing more than the capability of a node. You can think of it as the job the node has to fulfill. And a given node in your cluster can have more than one role. A role is declared in configuration, and it's literally nothing more than a string. It's a name of a role. It's a named responsibility. What you can do with this is you can have cluster-aware routers, and they can target other nodes in the cluster based on their role. What that could mean is you can have a router deploy actors onto another node in the cluster based on its role. So you could say, I want to remotely deploy my actors onto nodes that are of the role tracker, for example. Or if you had a group router, your router could say, I will only send my messages to actors at path/user/foo and only on nodes that are in this particular role. Again, tracker, for example. I'm going to introduce you now to one of Petabridge's sample applications to show off clustering, roles, cluster-aware routers, and a lot of other important concepts that we don't have time to cover in this video. This is our WebCrawler sample. The WebCrawler is exactly that. It's an application we built that's a scalable web crawler built using microservices in Akka.net. Basically, you get to put in a URL, and then the cluster will go crawl the URL. You can submit many URLs at once, basically until you run out of CPU or network bandwidth. And you can just keep doing this, and you can add more crawlers on demand to the crawl job in order to scale it out. So there's a few roles at play here. Those are web, tracker, and crawler. First, we have the web role in the top left. This is the front end, the user interface, where you input the domain you want to crawl. So you could type in http cnn.com. That submits to the tracker roles in the bottom left. The job of the tracker role is to keep track of what crawl jobs are in progress and to make sure that we don't have duplicate crawl jobs going for the same domain. So we wouldn't want to be having two entirely separate crawl jobs of CNN going at the same time. That would be a waste of resources. So then we have the actual crawler roles in the bottom right. These are the scalable services that actually do the crawling, the downloading, the parsing of whatever websites you put in. So the tracker roles are very stateful. They are tracking the state of the various crawl jobs. The crawler roles are stateless. They are just doing work. They are command processors. Now, these are all linked up within a cluster, and they form the cluster using Lighthouse, which is the dedicated seed node tool that Petabridge has open sourced. They form a cluster by all talking to Lighthouse initially, then they form a cluster with each other, and then assign work using their roles. I encourage you to go through the sample in depth. We have spent a lot of time thoroughly documenting it, explaining exactly what's going on, but it goes way beyond the amount of time we have in this video, but I will link to it and you should go check it out. But now, just to get you excited about it, I'm going to at least show it to you and show you how the web crawler works and talk you through it a little bit. Okay, I'm going to show you just really quickly a demo of what the web crawler sample looks like. So here I am inside the web crawler solution, which you can get on GitHub. So then you can see I have Lighthouse already running here. So again, Lighthouse is my dedicated seed node. It's living at localhost port 4053. And it's just going to be a dedicated seed node for the rest of the web crawler. If I go into app config, down here to cluster, there's my seed node. That's Lighthouse right there. So everybody's going to be looking to Lighthouse on this port at this address to form the cluster. And I'm going to show that to you now and fire it up just so you can get an idea of what this thing looks like when it's up and running. Screen, let me bring those up. So here we've got the tracking service and the crawl service, and then I have Lighthouse right here. So as you can see with Lighthouse started up, everything was good. And then there was a brief bit of time where things were figuring themselves out. And then you can see that the leader, which is Lighthouse in this case, was taking them off, but then was moving them here to up. And you see tracker and crawler right here. So then over here on tracking service and crawl service, you can see them being welcomed from Akka TCP web crawler at 4053, which is actually Lighthouse. So crawl service and tracking service are now in the cluster. They know about each other and they were welcomed and they formed a cluster with Lighthouse. So these three are now in a cluster. So let's go ahead and fire. We're going to crawl cnn.com. So that should kick off here in just a second. So, okay, good. That's all. Now the crawlers are being fanned out. The work is being reported back through the tracking service to the front end. And what we're going to do is we're actually going to launch another crawler, which is going to join the cluster and should start picking up work. Yeah. Okay, good. So now we have 2 crawlers running, and the tracking service is just sitting there doing its thing, tracking. So these crawlers are now working away. They are now collaborating. So, okay, so at this point, we have a fully up and running cluster that is crawling away on CNN.com, and we were able to elastically scale the cluster, albeit in a small way. And we were able to add crawlers to the cluster that were not there in the beginning, and they were able to join and dynamically expand the cluster and start picking up work. Great, now you've seen WebCrawler for yourself, and I encourage you to go in depth on it and really read the code, read the explanations we've put there, because it covers everything we've talked about in this video and more in depth. You can get the entire set of code for yourself from our code sample repo. Go ahead and click here on this link, and that'll take you to it. Finally, thank you so much for watching and sticking with me through this video. I really, really hope that this has helped you get an understanding of what Akka.Cluster is, what it does for you, and how to set one up and get it going. Please subscribe to our YouTube channel for more tutorials. And please also check out our advanced Akka.Cluster training, which goes way in depth and gets into how to operationalize Akka.Cluster, combine it with DevOps, do zero downtime cluster upgrades, message and cluster versioning, and much, much more. Again, thanks so much for your time, and I hope this has really been helpful to you.